Jason and Romero.
John's on tilt trip.
Sorry. Okay. Well, I still have to mark maps in. I just marked them whether you're here or not. And Jaden. All right. Good morning, guys. Welcome back. We had a handout on the front desk that if you did not grab, you will need to go and get. And we have 6 more class periods, including today, the 4-year semester exam. So we're going to spend a couple of those on the last section that I told you we still had 1 more to go. That is going to be section 5.3. So the notes should be numbered as 52 for that. So I'm going to go through all of that with you, of course. And then we're going to start number 53 where you get in some practice on it as well. And you can see we do a 5.3 quiz. It'll be on the 4th day back, so we spend 3 full class periods on this before we quiz it. Today would be day 1 though. And then just a heads up, we have a meeting this afternoon, but most years with the 5.3 quiz, we count it as a 50-point quiz, a 50-point major quiz. It's a little bit different than the other units because usually you do a section quiz, and then test over all of it, but we don't have time to do that at the end of the semester. So it's just this one last section. We will quiz it, and if we decide to do what we've done the last couple years, it'll be a 50-point major, so it'll be like a half test, basically. So I don't know if that is what will be decided again for this year, but probably so. Just a heads up. Okay, so let's talk about what section 5.3 is about. I did give you a heads up that factoring was a big part of this. But section 5.3 is all about solving equations, specifically equations that have some kind of trig function mixed in there. Now, the good news is most of these questions don't really require much additional knowledge besides unit circle and knowing how to write your answer. There's 2 ways that you will be asked to write your answer, either like this or like this. In the notes, we're going to go ahead and write it both ways every single time, but on the actual quiz, on the practice quiz, and on the book assignment, they only ask for 1 at a time, so you need to pay attention to the directions. Okay, but solving something like this with a cosine x actually works a lot like solving this that's just a regular x. I pointed this out with factoring, but this is true throughout most of algebra. So over here, I would expect you to start off by undoing subtract. So over here, you should do the same thing. Start off by undoing subtract. The next thing you should tell me over here is undo times with divide. So over here, you should undo times with divide. A lot of these questions, the solving part is exactly the same as regular algebra stuff. What is different, the second half of the question that's different, is in algebra, you're trying to solve for x, so you would get to say I was finished over here. But for us, we don't know what x equals, we know what cosine x equals. So we still have to use the unit circle. So we go all the way around the unit circle once, and think about everywhere where cosine is a half, positive a half. That would be when x is pi over 3 and when x is 5 pi over 3. So if the directions say just list out the answers from 0 to 2 pi, that would be your 2 answers. Those are the 2 values that make cosine a half, and when cosine is a half, 2 times the cosine minus 1 is what gives you 0. But when it says solve, this implies that it wants everything. So not just the stuff within 1 rotation. So I could go all the way around the unit circle 2 pi, add pi over 3, and as long as I land in that spot, it's going to be coterminal to pi over 3, and coterminal means it lands in the same spot, so it's got the same sine and cosine. So everything coterminal to this needs to be part of our solutions, And everything coterminal to this needs to be part of our solutions. So what we will do is we will say x could be pi over 3 plus any integer multiples of 2 pi. So if you want to go around the circle 50 times, where n is 50, you're going to land in that spot, so cosine is going to be a half. And then to get this guy and all of his coterminal angles, you would say 5 pi over 3 plus 2 pi n. But plus 2 pi n, and you might want to put this in words, this is getting all the coterminal solutions. When it says solve and it wants everything, it wants all the answers, no matter how many times you have to go around. Whereas solutions between 0 and 2 pi, you just need to state the angles between 0 and 2 pi. So for the next 3 questions on our notes, it's basically going to work out the same. We're going to talk about how to do it the old-fashioned algebra way. I'll try to point out a few algebra mistakes that students often make. But when we solve, we get down to this. We go to the unit circle. We name the spots where that happens within 1 rotation for these directions. Add 2 pi n for those directions. And then that is about half of section 5.3. So to continue on here, question 2, this solves a little bit differently, but again, I've set these up so that you can compare and contrast how if you can solve this from algebra, then you should be able to solve this for us. So anytime you have a quadratic, you should always, always, always try to get everything on one side set equal to 0. So whether that is x's or cosine x's, that should be your first step. Get everything on one side set equal to 0. The reason why you want to do that, and what you did a lot in Algebra 2, is you then factored this, and of course it's important that you factor it correctly. So if you can factor it quickly with guess and check, great. If you need to slow down and do the product sum method or some other method that you've learned before, then that's fine too, but you've got to be able to factor it. And if this factors as a 2x plus 1 times an x minus 1, this is going to factor as a 2 cosine x plus 1 and a cosine x minus 1. The x's are just cosine x's. It's the same thought process, the same logic, same methods. Now, the reason why you wanted factors multiplied together to equal 0 in algebra class is if you can make this be 0, 0 times anything gives you 0, or if you can make this equal 0, then you don't care what that is, because 0 times anything gives you 0. So we're going to do the same thing over here. I'm going to set this equal to 0 and solve, and that would be when cosine is negative 1/2. Set this equal to 0 and solve. This would be when cosine is 1. And other than looking more difficult on the right, I've not done anything different on the right than I've done on the left. I still set it up the same way because it's like a quadratic. I still factored it the same way. I still set each factor equal to 0. I set each factor equal to 0 and solved. What is different, and where you need to put some focus because this is not consistent, is now we need to apply this to the unit circle and think about when is cosine negative 1/2. Okay, so when is cosine negative 1/2? And when is cosine 1? And then we need to be ready to give our answer in either format that has been asked for. If they want you to spit out the solutions between 0 and 2 pi, we're just going to name these. It could be at 0, at 2 pi over 3, or at 4 pi over 3. Plugging in any one of those angles into the original equation should make it a true statement. 2 times the cosine of any of those angles squared plus the cosine of the same angle should be the values that give you 1. And then if the directions instead say solve, that wants the coterminal angles as well. So you could say x could be 0 plus everything coterminal to it, plus 2 pi n. X could be at 2 pi over 3 plus all of his coterminal solutions. And x could even be 4 pi over 3 and any of his coterminal solutions. So it's a little tedious, but it's not any harder than writing them the other way. But there's one catch here. And if you put this on the quiz, I'm perfectly happy with this. I would give you full points for it. But you need to at least be familiar with another way to do this, because when you check your answers in the back of the book, when we move on to the book assignment, they're not going to write it this way. So sometimes you need a bunch of statements, but sometimes you can condense these. In fact, this one you could condense into one single statement instead of 3 statements. So the reason why this works in this question is, if you notice, to go from this answer to this answer, I would need to add 2 pi over 3. But then to get from here to here, I could also add the same value, 2 pi over 3. And then if I go from here to here, I could add 2 pi over 3 again. So really, you could just say start at 0, and instead of going all the way around multiple times, 2 pi n, just go 2 pi thirds n. And then of course adding 0 doesn't really do anything, so we don't need to write that. So when n is 0, you get this spot. When n is 1, you get this. When n is 2, you get that. When n was 3, you would be back to 2 pi, and then you start getting coterminal solutions. So this one statement is the same thing as these 3 statements. Again, I personally have no preference whether you write 1 statement or 3 statements. You'll see even in our notes there's times where this is much more convenient, where you're going to prefer this because it's easier than writing a bunch of things down. But you at the very least need to understand, when you check the back of the book and you see this as an answer, you need to be able to look at your work and make sure that it's still okay, even if you don't want to write it like that. Okay, so on to question 3. 3 and 4 both have a common algebra thing that I know you've seen and heard before, but lots of mistakes on it. So trying to help you avoid those. So the most, and honestly, you probably need to write yourself a little note here. This is usually the most common mistake on the quiz. And I say that every year, and it still stays the most common mistake. What you get tempted to do in this, algebraically, is to divide both sides by an x, and you get x equals 1. The problem with this is, and you should note, never divide both sides of an equation by a variable, like I just did. I'm going to go back and erase that in just a second. The problem with doing that is you lose answers. 1 is not the only solution to this answer, or to this equation. What is something else that's the same as itself squared?
-0.
-1 squared is +1, so those aren't the same. But 0. You see how 0 also satisfies that? Okay, of course, most of the time equations are too complex that you don't want to guess and check in your head. So what you should do is don't divide both sides by x, because you lose an answer. You should do the exact same thing I said in question 2. If it's a quadratic, bless you, move everything on one side set equal to 0. If it's a quadratic, you should try to factor it. This problem, the factoring was GCF. Set this factor equal to 0 and solve. Set this factor equal to 0 and solve. In algebra, you'd be finished because you know what x equals. for us, we need to set cosine x equal to 0. That one's already solved. And set cosine x minus 1 equal to 0 and solve by adding the 1 over. And then the only unique part to this that is not really algebra logic is we need to think about everywhere where cosine is 0. Those could be answers. And everywhere where cosine is 1. That could be an answer. Now this spot, should I call this angle 0? Should I call it 2 pi, or does it matter?
Doesn't matter. You should use 0.
Why should I use 0?
Because 2 pi isn't included.
Very good. You got to pay really close to these directions here. The reason why there's a bracket on 0 is it's saying include 0, but the parenthesis on 2 pi means you don't include 2 pi. So basically, don't call that angle 2 pi because we're not going up to 2 pi. We're going up to it, but not including it. But you can include 0. So it is important that you name that based on the directions. So there's 3 places where cosine is either 0 or 1. So if the directions ask for that, you're done. If the directions ask you to solve, you can say pi over 2 plus everything coterminal, 3 pi over 2 plus everything coterminal, or 0 plus everything coterminal. And I didn't do 0 plus 2 pi n because adding 0 doesn't do anything. Now, even though these 3 are not equidistant, if this was a question in the book assignment, they are still going to condense this down into 2 statements. So again, when you do your work, I'm fine with you not doing it that way as long as you're sure it's equivalent. But what they would say is this one's kind of on his own, so you still need the 0 plus 2 pi n. But these 2 red dots, they're equidistant. You could add pi to go from this one to this one, and you could add pi to go from this one to this one. So instead, you could say x could start at pi over 2, and instead of going all the way around, just go halfway around. This one statement is equivalent to both of those statements. These are going all the way around, so they're hitting the unit circle half as often. This is only going halfway around, so it's hitting it twice as often. That's why they're still saying the same thing. Again, just to be clear, and I'll try not to say this a million times, but on your quiz, I don't care which one you do. But in the back of the book, it's going to look like this, so you need to understand why they have 1 pi n here and not 2 pi n, and why they only have 2 statements instead of 3 statements. Okay, last of the regular algebra stuff that should look familiar to you, and then we'll look at a few exceptions on the other pages. But on this one, usually you don't do this with a quadratic, but we can get away with this because it only has x squares and not x's. We could undo the minus 1 with the plus 1. We could undo the times 2 with the divide 2. And the reason why I threw this one on your notes is because the next step is very important here. Not anything different you've never heard before, but you guys are not consistent with it. When you take the square root of both sides, you have to remember plus or minus, or you lose half of your answers. Same thing here. To get rid of a square, I want to square root the left side, so I have to square root the right side. When you square root both sides of an equation, you have to put the plus or minus. Now again, in an algebra class, this is probably good enough because that's what x equals. For us, we need to figure out where this happens on the unit circle. And since this does not look familiar yet, you may need to review how to take the square root of a fraction. Square root of a fraction is like taking the square root of the numerator over the square root of the denominator. And if it still doesn't look familiar, it's probably because you need to rationalize it. But the solution to this would be anywhere where sine is positive square root of 2 over 2. And negative square root of 2 over 2. If you forget the plus or minus, you're only going to get 2 of those two. So, if that's what the directions call for, Jonathan, is there a reason you don't have this written down? Okay, I did not hear that, but okay, if the directions say solve, you can see this is where the condensing is going to come in handy. Because without condensing, you're going to have to say pi over 4 plus everything coterminal. Also 3 pi over 4 plus everything coterminal. Also 5 pi over 4 plus everything coterminal. Also 7 pi over 4 plus everything coterminal. Or you could squeeze all that into one statement. Anybody want to take a stab at what you think the one statement would be?
Pi over 4 plus pi over 2 n.
Very good. So first location is right here, and then if you notice that you just have to add pi over 2 to get to the next spot, and then add pi over 2 again to the next location, add pi over 2 again to the next solution spot, and then if you add pi over 2 again, you start getting coterminal angles. This one statement is the same thing as those 4 statements. I don't care how you write it, but the back of the book's going to write it this way. So the main thing I need you to get out of this question is when you take the square root of both sides, you need plus or minus. I'm sure you've heard that 100 times before, and I'm going to say it 100 times more in the next 3 class periods before the quiz. And it's probably still going to be one of the most common mistakes. If I was you, I'd write it at the top of your page and glance at it before you started the quiz, but that's how I would do it. Okay, after that, we've got a few exceptions, a few questions where we need to be a little bit more creative. So these don't just solve with normal algebra stuff. I'm doing subtraction and multiplication, getting everything on one side for a quadratic so you can factor it and set the factors equal to 0. Or same thing with question 3, making sure you don't divide both sides by a variable, and taking the square root of both sides, not forgetting the plus or minus. Question 5 is different. This part's a typo. That's supposed to say cosine x. This one's different because it's got some sine stuff in it and some cosine stuff, which is almost like 2 different variables. And you can't solve an equation with 2 different variables. So all we have to do is make a substitution so that it's all written in sines or all written in cosines. So, in fact, I think you still have this on your desk, but one of the most important trig things that you've been exposed to this semester are the 3 Pythagorean identities, specifically the first one. And looking at it, sine squared is always equal to 1 minus cosine squared. So right here, instead of saying sine squared, you could say 1 minus cosine squared. And I'll leave the rest of the question alone. Now, it doesn't mean that it's an easy question, and I still have a few more steps to finish, but now it's no different than the first 4 that we did. That step is what you need to highlight and potentially write a note to yourself. Change this to cosine stuff. So that it's all in terms of cosine. Now, this is like a quadratic. So I've got some stuff squared. I've got some variables that are not squared. And I can combine the plus 1 and the plus 1 to get plus 2. If this intimidates you, just like I did for you on the first 4 questions, there's nobody stopping you from just sidebarring real quick and changing all the cosine x's into just x's and asking yourself, how would you do this? I think most of you would probably multiply everything by a -1. So that's fine over here as well. Then most of you would go about factoring So same thing here. If it's an x minus 2, this should be a cosine x minus 2. If this is an x plus 1, this should be a cosine x plus 1. If it was algebra, I would set this equal to 0 and solve, and set this equal to 0 and solve. So I need to do the same thing with trig. Set each of those equal to 0 and solve. And then to finish, I need to think about where this happens on the unit circle. So what angle between 0 and 2 pi has a cosine of negative 1? Where's cosine negative 1? You have to say it louder. I can't hear you. At pi? Okay. So pi is a solution. Understandable to be rusty with unit circle with your break, but still going to be important here. Okay, what about where's cosine going to equal 2? At 2 pi, cosine is 1, not 2.
It's not a unit circle.
That's true. So, if you think about the sine or cosine graphs, if you think about the range of sine or cosine, or you think about unit circle, the biggest and smallest value that sine and cosine can be is negative 1 to 1. So, it's not that I did anything wrong, it's just that cosine never equals 2. So that side just happened to not give anything else. So, there's the answer if the directions look like that. And do a plus 2 pi n, so you get all the coterminal answers if the directions look like that. So again, I basically solved it like any other quadratic with factoring and unit circle. Have to know how to write your answer at the end. But the unique thing about this question is if your equation has sine stuff and cosine stuff, make a substitution with your first Pythagorean identity so that it's all cosine stuff, and then that's not an issue from there on out. Okay, and then one of the next things, we'll look at 2 of these problems, but sometimes we'll give you questions, and this actually came up in my calculus class just randomly on a test review question a couple weeks ago. But you have to know what happens if you put a 2 next to the x, or a 3 next to the x, or a 1/2 next to the x. So really it's going to change, not too much, but it does kind of change the order you want to do this question in. So what I would recommend that you do is pretend like it's not 2x for just a second. Pretend like it's just 1x. And work the solve part of the question first. So sine x is negative square root of 3 over 2 when x is 4 pi over 3 plus everything coterminal, and then again at 5 pi over 3 plus everything coterminal. But there's a catch. I pretended like this was just a single x for my convenience to get me this far. But I haven't really solved for x. I have solved for 2x. Because there was a 2x there, not a 1x. I pretended like it was 1x to help me start this off, but I solved for 2x. So, to go from 2x equals to just 1x equals is I want to divide everything by 2. Divide this by 2, divide this by 2, and divide this by 2. Divide this by 2, divide this by 2, and divide this by 2. And if the directions say solve, you would be finished. So you can work it the same way, but then realize that you solve for 2x. Just divide everything by 2 before you circle that. Now, if you want the solutions between 0 and 2 pi, this is pretty tough to do. It's not just these two spots. In fact, when you put a 2 next to this x, it creates more solutions between 0 and 2 pi. And it's pretty hard to just reason through this in your head. But luckily, these two are like formulas that spell out for us all the solutions. So, using this top little formula, it says that one answer could be at 2 pi over 3. But you should get another one if you add pi to that. So, as a common denominator, pi is the same thing as 3 pi over 3. So 2 pi over 3 plus 3 pi over 3 would give me 5 pi over 3. Is 5 pi over 3 between 0 and 2 pi?
Yes.
Then we need to include it as an answer. Okay? Add pi again. 5 pi over 3 plus 3 pi over 3 would be 8 pi over 3. Is that between 0 and 2 pi? Okay, how do you know it's too big?
Because 6 pi over 3 is 2 pi.
Right. If the numerator was twice the size as the denominator, it would be 2 pi. So if that one's too big, that's how I know I've exhausted the top formula. You need to do the same thing with the bottom formula, though. Except this is not... Oh, yeah, it is. So 5 pi over 6 is an answer. But if you add pi to that, as a common denominator, that's like 6 pi over 6. So 5 pi over 6 plus 6 pi over 6 would be 11 pi over 6. Since that's between 0 and 2 pi, we have to include that as one of our answers. Add pi again. 11 pi over 6 plus 6 pi over 6 would be 17 pi over 6. Is that between 0 and 2 pi? No, because 2 pi would be 12 pi over 6. So that one's too big, and I know I have exhausted the bottom formula. There are 4 answers, 4 angles that you could multiply by 2, take the sine of them, and get negative square root of 3 over 2. You're probably not going to think of all 4 of those, just looking at the unit circle and trying to reason through it. Start with this, and then use these to come up with those. Okay, we're going to do another one like this, because I know this one's a little bit harder to see, but we'll do the same thing with question 7. But to even start question 7, we really should divide both sides by 2. You always want to undo as much basic algebra as you can. You want to get it down to a trig function equals something. So even though this is a 3x, I'm going to temporarily pretend like it is a 1x, so I can get started on this question. If it's a 1x, there would be a solution here and here. This is where cosine is negative square root of 3 over 2. And so I could say there's an answer at 5 pi over 6 plus everything coterminal, but also 7 pi over 6 plus everything coterminal. And the one big unique thing about this question is then you have to have the mindfulness here that I didn't solve for x, I solved for 3x. So, to go from 3x equals to just x equals, divide everything by 3, divide everything by 3. And if the directions say solve, you were finished. If the directions say give solutions between 0 and 2 pi, we're going to have to use these formulas to help us get all of these. So working extensively with this first little formula here, n could be 0, so one answer could be 5 pi over 18. And then it says you can get another answer if you add 2 pi over 3 to that. Well, I need this as a common denominator. So 2 pi thirds is the same thing as 12 pi 18ths times 6 times 6. So to add 2 pi thirds is the same thing as adding 12 pi 18ths. So 5 pi 18ths plus 12 pi 18ths would be 17 pi 18ths. That's between 0 and 2 pi, so I need to keep it as an answer. Add it again. 17 pi 18ths plus 12 pi 18ths would be 29 pi 18ths. That's between 0 and 2 pi, so that has to be listed as an answer. You have to try again, and this would be 41 pi 18ths, but this one is bigger than 2 pi. 36 pi over 18 would be 2 pi. That's how I know I have finished with the top part. Got to do the same thing with the bottom part. N could be 0, so 7 pi over 18 could be a solution. I could add 2 pi thirds to that to get another solution. That's the same thing as 12 pi 18ths still. So 7 pi 18ths plus 12 pi 18ths would be 19 pi 18ths. Add it again, that would be 21, 31 pi 18ths. That's between 0 and 2 pi. Add it again. You just have to keep adding it until you get an answer bigger than 2 pi. Because of that 3, there are 6 angles between 0 and 2 pi that make that equation true. There are 6 angles that you could multiply by 3, take the cosine of them, multiply that by 2, and get negative square root of 3. Not something you're going to do in your head. You need to understand what these two things are saying and use them to generate that list if needed. Of course, if you're lucky, it'll just ask for this and you can quit. But
Is there always going to be an even number of solutions?
No, I don't think that would always be the case, but often. Okay, any other questions about these two? Aaron, you need to get up. Okay. Okay, and we got 2 more questions to look at. We kind of already talked about these two, but I needed to explicitly say it. Not everything is possible. If you try to divide both sides by 5 here, or subtract 8 from both sides here, sine and cosine, if you think about their graphs, only go up as high as 1 and as down as negative 1. So sine can never be as much as 5. Cosine can never be as low as negative 4. So that comes up. And so I don't want you to waste too much time trying to make it work when some stuff just doesn't work. Okay, and then the last example that I thought would be helpful is sometimes algebra is not necessarily the most useful thing. So, for example, on number 10, the only algebraic way to do this, and I don't want to go through the whole thing, but it is okay in algebra to square both sides of an equation. As long as you do it to both sides, it's okay. But to square this, you'd have to FOIL it out. You're going to have some sine squared stuff and some sines and a constant. Square this, you've got some cosine stuff. So you would need to replace one of these with the first Pythagorean identities to get it all in terms of sines or cosines. Then you'd have to solve it like a quadratic and factor it and set each factor equal to 0, etc., etc., etc. I have to still warn you, even though that's a much longer process than what I'm about to show you, you need to be aware that when you do this, when you square both sides of an equation, you might be creating extraneous solutions. So extraneous solution is a solution where your work's right, your thought process is right, it would solve the previous step, that would solve the step before it would solve the step before it, but some of your answers may not solve the original question. And if they can't solve the original question, then they can't be real solutions. So I do not recommend trying to do this in algebraic way. What I would recommend is just do guess and check, because the unit circle only has 4 spots that are exactly one value away. Right here, sine and cosine are actually exactly 1 spaced apart. At pi over 2, they're exactly 1 spaced apart. And at pi and at 3 pi over 2. There's only 4 places. So you might as well just guess and check each one. So remember, sine is the y values on the unit circle, and cosine are the x values on the unit circle. So basically, if I can take away 1 from y and get x, then it should be a solution spot. So if I try that here, take away 1 from y, that would not equal x. Doesn't work at 0. At pi over 2, if I take away 1 from y, it does equal x. Pi over 2 is a solution, and everything coterminal to it, depending on what the directions want. At pi, if I take away 1 from y, it does equal sine or cosine. So pi is also a solution. And to try 3 pi over 2, if I take away 1 from sine, that would be negative 2. That doesn't equal cosine, which is 0. So that's not a solution. There's only 4 points to try, and only 2 of them worked. So if you are determined, if you want a good challenge, go for it the algebra way. But anytime it just says take away 1 from one of them to get the other one, it's a lot easier to just guess and check the 4 spots that are spaced out by 1. Okay, on your blank piece of paper, before I put the assignment back up, I do want to talk about the first 2 in the assignment, other than the vocab check, just because the directions kind of throw people off here. So, question 5 in the book assignment. Looks like this, and you can go ahead and just copy down with me because there's still another one like this. Question 5 and question 9, they don't even want you to solve these at the start of the assignment. All they want you to do is to check these answers. So they're trying to show you that as you work these questions, without a calculator, without the back of the book, without the class website, you could check your work. I mean, I guess it doesn't help you if you're missing some answers, but it does tell you if these are right or not. So, like any algebra problem, if you did the work and you got this as an answer, to check, you should try plugging it into the original problem and see if it gives you a true statement. This one does. So hypothetically, if you solve this equation and you got pi over 3 as a solution, you should be able to check and see that pi over 3 makes sense that quickly. You plug it in, and I was left with a true statement. If also within your work you thought 4 pi over 3 was supposed to be a solution, you can plug it in. Evaluate this. And once again, we were left with a true statement. So 4 pi over 3 would also need to be part of your work, part of your answers. So this is what they're expecting to see. They're not asking you to solve question 5, and they're not asking you to solve question 9. They're asking you to check the answers that they are providing for you on 5 and 9. They're just trying to show you that you can check pretty quickly and efficiently as you go through this assignment. So let me leave this up for another moment, and then I'll put the assignment up. Even though we do have some more class time on Thursday to work on this, obviously I want to try to help you guys get as far as possible and help iron out as many of the questions as you may get to. So go ahead and finish copying down the rest of the assignment. Do the question 9, that's like number 5. And then starting on number 11, they actually want you to solve. So solve. Make sure your answer matches the format of the directions, just like we did in the notes. And then you can move on. But about every 10 or 15 minutes here, until we run out of time, I will check in and give you a chance to ask some questions, as I usually do. So try to get 3 or 4 questions done, please, in the next 10 or 15 minutes.
Compass on
So you could find your way back.
it's
Okay, let's aim for about 4 minutes here, and then I'll try to help out with a question or two. let's check in here and see if I can help you get unstuck on a few. Of course, anything giving you issues early on in the assignment is likely to give you trouble later on as well. So, I know you only had about 11 minutes there, so maybe question 9, 11, 13, maybe 15. The ones you guys got to, any of those that you would like to discuss.
Can you do 9?
Number 9, okay. So number 9, again, is not asking us to solve. It's just asking us to check. So we're going to pretend like we solved this and get an answer of pi over 2 and an answer of 7 pi over 6. And if we want to know if those answers are even reasonable, we should plug pi in over 2 everywhere there is an x. So this would be 2 times the sine of pi over 2 squared minus the sine of pi over 2 minus 1. And what is the sine at pi over 2? Okay, so if I get 1 everywhere there's a sine of pi over 2, I'm going to get 2 times 1 squared minus 1 minus 1. So that's a true statement. So pi over 2 has been confirmed to be a solution. It solves the original equation. Do the same thing with 7 pi over 6. I plug it in everywhere there was an x. To see if that satisfies the original equation. And what is the sine of 7 pi over 6? It is negative 1/2. So this would be 2 times a fourth plus a half minus 1. So we get a half plus a half minus 1. Does that equal up to 0?
Yes.
So because that satisfies the original equation, we have just confirmed that 7 pi over 6 is a solution. This is what I would anticipate you would do at the end of your quiz, just to help you find some of your mistakes. Plug them in, see if they work. Now again, there could be a third solution or a fourth solution, so there's nothing saying that these are the only 2 solutions, but you can make sure this is supposed to be a solution by plugging it in and see if it works. You can make sure this is a solution by plugging it in and seeing that it works. And if it doesn't work, then you know you did something wrong at least. So, okay, but that was the last of the questions where they just wanted you to check. Starting with number 11, they want you to actually solve. So again, I know you haven't had a ton of time, but has anyone tried 11, 13, or 15 and gotten stuck? What you got? 15? Sure. Okay, and if you are not to 15 yet, you can take your choice here. You can go ahead and keep on going where you're at and watch the class recording later if you need help with this one, or you can just follow along now. It's up to you. Okay, so when I look at 15, I'm going to try to strip away all of the basic arithmetic stuff. Undo the minus 4 with the plus 4. Undo a times 3 with the divide by 3. Undo a square with the square root. I'm going to highlight plus or minus, because I took the square root of both sides, so I have to have plus or minus. This doesn't look familiar to me for a couple of reasons. So before I can start to think about unit circle, I have to clean this up a little bit. The square root of a fraction is the same thing as the square root of the numerator over the square root of the denominator. Oops. The square root of 4 comes out nice. The square root of 3 does not. And then the second reason this doesn't look familiar is because this is a secant value, and I don't memorize secant values. But you can take the reciprocal of the left side as long as you take the reciprocal of the right side. You got to do it to both sides to be equal. And then now this looks familiar. Now we are about ready for the unit circle. Cosine is positive square root of 3 over 2 in a couple places. He is negative square root of 3 over 2 in a couple places. And before I start to write down my answer, I would look at the directions personally. You don't have to write it both ways. This one just says solve, so that implies coterminal angles as well. So your answer could be pi over 6 plus everything coterminal, 5 pi over 6 plus everything coterminal, 7 pi over 6 plus everything coterminal, and even 11 pi over 6 plus everything coterminal. Those 4 statements would get you full credit on the quiz. I know the back of the book is not going to make it look like that though. So I will write the other way also. So these two are equally spaced, so I could combine them into one statement. Start at pi over 6 and just add 1 pi. And then these two are equally spaced. You could start at 5 pi over 6 and add 1 pi instead of 2 pi. These two statements are equal to those 4 statements. I suspect, and I honestly haven't even checked, but has anyone looked in the back of the book yet? No? Okay. I'll check. I bet they write it this way on the right though. So nothing wrong with what's on the left, but you need to at least know your answer is correct. I think if you were unsure, if you watched any of my class videos, I think I talk about them both ways, so that can help you. Yeah, they read it only the way on the right there. That's what I suspected. Okay, was there something more specific about 15 while it's still up there? Okay. For anybody else that was going to ask about 15, anything that jumps out at you? Okay, maybe one more before I set another timer and let you try a few more questions.
You do 11.
Sure. Okay, 11 wants to know the square root of 3 times the cosecant of what angles could you take away 2 and still end up with 0? Alright, well, I can undo the minus 2 with the plus 2. I could undo a multiply by the square root of 3 by dividing by the square root of 3. And I know I'm going to have to go to the unit circle, but I don't memorize cosecant values, so let me take the reciprocal of both sides. And it would be where sine is square root of 3 over 2. Now, should I have a plus or minus here? Because I had that on the last question. I should not. Only if you're square rooting both sides should you put a plus or minus. So you just need to think about where is sine this. That is at pi over 3 and 2 pi over 3. So this would be my answer if the direction said give the solutions between 0 and 2 pi, which does not occur until question 29. And since it says solve, I need to say this plus all of his coterminal angles and this plus all of his coterminal angles. And you cannot condense that into a single statement because these two are not equidistant. The distance from here to here is way different than the distance from here to here. They have to be spaced out equally to condense into less statements. Okay, so a pretty common thing. Usually there's a few steps of algebra you can do. You will always need the unit circle, and then you always need to put thought in what your answer needs to look like. But the basic algebra in this question was undoing minus, undoing times, and taking the reciprocal of both sides. Okay. Okay, let me do one more 10-minute timer. So try to get another 2 or 3 questions done. And then I will answer those, and we'll have about 10 minutes. So then I'll tell you how far you need to be between now and Thursday. Also, I don't know if I mentioned this at the start of class, but this is a B week, so I will see you guys on Friday. This Friday I'll see you, next Friday I will not. All right. One more chance to try to get a little more help before we run out of time today. Some other questions that you've tried. Yeah, what you got?
Let's do 15.
We already did 15. Somebody already asked that one last time. 23? Okay. Okay, 23 would like to know 3 times the tangent cubed. When is that equal to just tangent to the first? So again, what I would do, and again, that's always optional, but if you, especially if you have trouble starting a question, just change all of the trig stuff to just regular x's and then see if that gives you a hint on how to start here. What I would want to do here is subtract the x over. So my best guess on how to start this would be to subtract the tangent over. Then I see that I could factor out an x. It's got a GCF. So factoring out a GCF is always a good idea if possible. So for us, that's not really an x, it's a tangent x. Okay, now that I've got 2 factors being multiplied to 0, I could set this factor equal to 0. It's already solved. I could also set this factor equal to 0 and solve. So I'll do the same thing over here. This would be where tangent is 0, and also where 3 tangent squared minus 1 is 0. So this one, you still need to add the 1, divide the 3. You still need to square root both sides. We'll highlight the plus or minus. And before this part looks familiar, we have to know how to take the square root of a fraction. And you probably want to rationalize it before it starts to look familiar. But eventually, we get some stuff that looks familiar to the unit circle. There's 2 times where tangent would be 0. Remember, tangent is like sine over cosine, so anywhere where sine is 0, tangent would be 0. So that happens at 0 and at pi. And then anywhere where tangent is square root of 3 over 3, positive. So big shortcut, if you memorize those tangent values like we had talked about a couple weeks ago, you get to go straight to that. If you don't memorize those spots, you're going to have to think about where tangent's positive and negative. Tangent's positive in 1 and 3, and you can guess and check by doing sine divided by cosine, but it would be pi over 6 and 7 pi over 6. Yes?
Where do you keep the plus minus?
Oh, I'm sorry, yes, it should. It should be plus or minus. So also those. So hopefully you guys can learn from my mistake there. Just because I remembered it, I didn't remember it long enough. So there are 6 spots that should make this true. Like our first 2 questions in the book, you can actually plug in pi over 6, see if it works. Plug in 0, see if it works. Plug in 5 pi over 6, see if it works. It's a little tedious, but you could do that. But to put all of this into the format that it wants, the long way is going to be to make 6 statements. 0, everything coterminal, pi over 6, and all of his coterminal, 5 pi over 6, and all of his coterminal, pi, 7 pi over 6, and comes up here, 11 pi over 6. There's 6 places within one rotation, so there could be 6 solutions here. But they probably, I'm guessing the back of the book probably condenses this into 3. You could get both of these because they are pi units spaced apart with that statement. These two are pi units spaced apart, so you could just say pi over 6 plus pi n, and that would include this one as well. And then these two are equally spaced apart, so you could do 5 pi over 6 plus pi n. These 3 statements are the same as those 6 statements, but these 3 statements is how I would expect the back of the book to do it. Yeah.
You do 5B.
I already did that. Okay, so that was a pretty long question, but is there something, do you at least see where to get past where you got stuck initially? Okay. Okay, so we've got about 8 minutes left, it looks like. So try to do maybe 1 or 2 more questions, but I need to tell you where you need to be by Thursday. You do not need to try to finish this book assignment. We have enough class time that I can give you more class time later. However, you can see that under the homework, it says continue on 53. So really I'm just asking that you do like 2 or 3 questions. Not because I'm not going to give you more time, but because I think it'll help you if you force your brain to think about these for just a couple questions between now and Thursday. So do 2 or 3 more for homework, and consider working on your semester exam review. You should be very close to finished. In fact, if you just did 1 a day, I think you would finish easily. But consider doing 1 or 2 questions on your semester exam review too. Yes?
When is the semester review due?
The day of the semester exam. But for people who are trying to exempt, you're not officially exempt until I see it finished and stuff. So if you're wanting to exempt, you'll probably want to have it done before the day of the final. If you guys don't check your student emails very often, you need to, especially if you're trying to exempt anything, because the form to apply for exemptions opened up yesterday, and I think it's open from now until next Monday. And if you don't apply on time, you won't get to exempt anything. So we do allow exemptions in this class, but you do have to meet all the regular school assignment or school requirements, and you have to finish the semester exam review. So. All right. So try to finish up the question you're on. Jot down to do 2 or 3 more for homework. Jot down to do a question or 2 of your semester exam review for homework. And we will spend more time on this on Thursday. You don't need to do more than a couple questions, unless you did not get much done in class. If you did not get much done in class, you need to catch up to where everybody else is.